verify the Fibonacci formula. Okay, all right. Base case, easy, right? Yeah. 0, you plug in 0. 1 minus 1, 0. Easy. 1, let's plug in 1. Is that easy? Okay. Plug in 1. Okay. How to handle this part? The denominator 1 plus root 5. How do we handle that? The denominator is an irrational number. Any idea?
Try to get its conjugate. So
Right, conjugate. We multiply its conjugate. The conjugate means 1 minus root 5. Okay? Let's multiply 1 minus root 5, both top, bottom, at the same time. Yeah. So what happened? Yeah. We will get this. Yeah, because after cancellation. Oh, we multiply root 5 minus 1, because that's positive. Okay? Positive, negative. Can you see that? Yeah. So I hope I do not need to do it. Okay? Yeah. So you get that. All right. Then add up these two numbers. 2 root 5 cancel 2, root 5 cancellation, you get answer 1. So we verify another base case. Yeah. Here, as practice, let's verify another one as a practice. Okay? But you can see it becomes harder and harder. When you increase the exponent, the size number, it becomes harder and harder. Okay? So let's look at how hard they are. Yeah? Because this time we can use this number to replace that number. Okay? Use this number to replace that. Okay? So we expand, we use the formula, expand it. Okay? The cancellation, right? Yeah, because minus, no cancellation. Okay? Minus, no cancellation. Okay? Yeah, but other numbers cancel out. Okay? 4 times root 5, 4 cancel, root 5 cancel equals 1. Okay? So this case, we can also verify they are the same. Okay? Yeah. How about this case? Scary, right? Now it becomes harder and harder. Too much work, right? So do you feel too much work doing that? Yeah. So, but here, when it is hard, let's try to find a smart way to do it. How about that? Let's try to use a smart way to calculate it. Okay? Not this way. If we do this way, then, too much work. Okay? Let's use a different way to calculate it. Okay? So let me show you in the next slide how to calculate this case. All right. We reduce the degree reduction to calculate it. Yeah, because this degree too high, right? We want to reduce this degree. When the degree is smaller, then it's easier to calculate. Okay? Reduce the degree. How do we reduce the degree? Okay? The question. Strategy. Reduce the degree to make the calculation easier. But how do you do it? How to reduce the degree of theta cubed? Okay? Yeah. Theta is a special number. We need to use the property of theta. There is some property. For theta, we can use to do the degree reduction. So what is that property? What is that property? Okay? Theta is a root of quadratic equation, right? Yeah, theta is a root. We solve this equation and get a theta solution, positive solution. That's theta, right? Can we plug in theta into this equation and it's 0, right? Yeah. Because that's the meaning of the root. So we plug in. Theta satisfies this equation. Oh, not theta, sorry. Phi. Yeah, phi. Okay. Phi satisfies this equation. All right. Can we rewrite in this way theta squared equals theta plus, theta again, phi. Yeah, phi. Can we write in that way? Phi squared equals phi plus 1. When you look at this one, do we do degree reduction? Left-hand side, degree square. Right-hand side, linear. That's degree reduction, right? Degree reduced. So that property we can use for degree reduction. Okay? Now, let's apply on phi cube, degree reduction. Okay? To make this calculation easier. How about that? Okay? So let's do it. Phi cube equals phi times phi squared, right? Phi times phi squared. We split. Square, do you want to use another expression with lower degree to replace phi squared? Yeah? Lower degree. Phi times phi plus 1. This time degree lower, right? Lower. All right. So phi squared plus phi. Can we use phi plus 1 to replace phi squared to make the degree lower? Right? 2 phi plus 1. So now this is the lowest we can get. How about that? Yeah. The cube degree 1. How about that? Degree 3. Reduced to degree 1. How about that? Okay? Yeah. Then, but the question is 1 over phi cube. The cube term is at the denominator. How do you reduce that degree? Right? We need to reduce that degree at the denominator. Okay? All right, let me show you. This one a little harder, but we still use this property to reduce the degree. Okay? All right. 1 over phi cube. When we start. Okay? This time a little tricky. How do we reduce? Okay? The idea is if we can do cancellation, both top and the bottom can cancel out some phi terms, some phi, top, bottom, then we can reduce. But the numerator is 1. There is no phi. You cannot do cancellation. Right? You cannot do cancellation. It's 1. Okay? Can we change 1 to some term phi? Can you see 1 here? Do you see 1 here? Can we represent 1 as phi squared minus phi? Right? 1 equals phi squared minus phi. Okay? So you replace this 1 by phi squared minus phi. Can you do cancellation? Right? Now you can do cancellation. Right? Degree lower, right? Square. Okay? How about this? Phi minus 1. Now we cannot do cancellation. But do you have way to do another cancellation? Yeah. Can you replace this 1 by that phi squared minus phi again? Okay? Replace that 1 by phi squared minus phi again another time. Right? When you do that, you get 2 phi minus phi squared. Can you do cancellation? Right? Do cancellation. Okay? 2 over phi minus 1. So you get this. Now, when you add these two numbers, 1, negative 1 cancel out. The remaining is that much easier than before. The remaining we have, okay? Now when you add up these two terms, take that 2 out, you get that.
I got how you transformed from the first one to the second one.
Okay.
And then from there, you turned the phi squared into the phi plus 1, and then you had that minus 1, or how did you go?
Cancellation. Can you cancel out one phi?
Oh, from
Divide it, yeah. Top, bottom.
Yep.
Yeah. Cancel out. Then replace by 1. Cancel out. See? Yeah. So you get that. You simplify, you get that. And we already calculated that's Fibonacci number of 1, right? Fibonacci 1, that's 1. 2 times 1, okay? 2f1, okay? That's 2. That's 2. See? Yeah. So you can see, after these experiments, now we have more confidence this formula is correct, right? Yeah. Yeah. We have more confidence. It's correct. But we still need to use induction to prove it. Induction. Okay? Yeah. All right. Next step, induction. Induction. Okay? Yeah.
Wait, one more last thing. Can you go back? How did you do the last step of that, where you went from phi to phi minus phi squared? That
Which step?
That, the one you're pointing at there.
This step? All right. Cancel out one phi.
Yes.
So you have phi, all right?
2 phi minus 1.
Right. So 2 minus phi, right? Okay. The first term 2 over phi. The second because minus phi over phi. See, that's a minus 1. Right? So you just split the term. You write term by term. Yeah. 2 set. Yeah. Yeah. Then
Yeah, now we see.
right. So yeah, we have that. Yeah. All right. Next, induction.